Okay, so organic chemistry, chapter 10 for core and chapter 20 for extended. We'll be covering both of those in today's presentation. Okay, so sorry, this one's a bit of a word heavy slide, but we'll go through it a bit slowly. So yeah, so homologous series, what is it? Important to know the definition. Usually you get 1 or 2 marks for these in paper 2. So it is a series of compounds of the same family with the same general formula, which differ from each other by a common structural unit. Sorry, I have no idea why that's on a different line. So what are the features of a homologous series? So successive members differ by a CH2 group. So basically each, like if you go up in size, each size is bigger by just CH2. Members are represented by the same general formula. They show a graduation in physical properties. So the boiling points increase as the carbon chain increases because this increases the van der Waals forces. Density and viscosity increases as carbon chain increases. So those are the physical properties. So they show a gradual change. Members have similar chemical properties. Sorry, I'll just hide this, so I'm not sure if you guys can also see that. Members have similar chemical properties because of the same functional groups, which are the reactive parts of the molecules. Also, you guys are more than welcome to take screenshots at any time if that helps you with your revision in your notes. Okay. Cool, so types of formulas. There are 3 different types that you need to be aware of. So, sorry, 3. The first one is the empirical formula. This is the simplest whole number ratio of atoms. So, again, sorry about that. So the examples are at the bottom of molecular and empirical. So, and then the molecular formula is the actual number of atoms of each element present in the molecule. So I found 2 examples for you here. So butane, the molecular formula is C4H10. But, there are 4 carbon atoms. The empirical formula is the simplest whole number ratio of these. So if you divide that compound by 2, it becomes C2H5. The same thing for octane. Octane's molecular formula is C8H18. It has 8 carbon atoms and 18 hydrogen atoms. And its empirical formula is the simplest whole number ratio of those, which becomes C4H9. It's basically when you divide it by 2. Okay, so that's the empirical and molecular. The structural formula is instead the representation of the molecule, showing how the atoms are bonded. So there are different types of structural formulae. So the full structural formula shows every bond. So if you have like carbon and then you bond it to the hydrogen, and then to the O, and then to the H, for example, that would be a full structural formula with another H on the side. Condensed emits bonds. So it's when you write like CH3, then you do a bond and you use CH2, CH2, CH3. Stereochemical is when you show the relative positions of the atoms and groups around the carbon atom in 3D. So if you look at the molecule, so methane on that side of the screen, you can see how it's actually in 3D. So the like blocked lines, the full just normal lines, that means the hydrogen is in the plane of the paper. The dotted ones means that the hydrogen is pointing to the back of the paper, and the triangle one means that it's pointing at the front. Okay, and that's how you show it in 3D. Again, please let me know if you guys have any questions, and yeah, I'll just keep popping backwards and forwards in case you guys do have any. Okay, so terms you guys need to be aware of. Saturated means that it contains only single bonds. Unsaturated means it contains a certain number of either double or triple bonds. You need to know the structure of benzene. It can be represented like that. Each corner basically means a carbon atom. So there are 6 carbon atoms, and each of these carbon atoms are bonded to a hydrogen atom, which aren't shown on the representation there. Okay, aromatic compounds or arenes are unsaturated compounds containing a benzene ring, and aliphatic compounds are saturated or unsaturated compounds that do not contain a benzene ring. So the difference between aliphatic and aromatic is just the presence of the benzene ring, essentially. Okay, straight chain hydrocarbon is Okay, so definition of a straight chain hydrocarbon is a continuous or unbranched chain of atoms. That one's kind of important to know. Okay. Ooh, sorry. So now we'll move on to the classes that you need to be aware of. There are lots of these, 2 slides full. These are super important. It basically makes up the whole of organic chemistry because each one of these functional groups basically changes all of its physical and chemical properties. So the simplest one we can think of is an alkane. That's only contains carbon and hydrogen and only single bonds. The functional group is an alkyl, and the suffix, UPAC suffix name is ane. Then alkene is when it contains a double bond between the carbons. Functional group is alkenyl, and it ends in ene. Alkyne is when so triple bond between the carbon atoms. Functional group is called alkenyl, and the suffix name is ine. Oh, also, let me know if the screen is too small, and I'll try and make it a bit bigger if you guys can't read any of it. Okay, alcohol is when the carbon chain is bonded to an OH group. This group is called the hydroxyl functional group, and the name ends in enol, like ethanol. Aldehyde is when the carbon is double bonded to an oxygen, a hydrogen, and another carbon atom. The key difference between an aldehyde and a ketone is that a ketone is the carbon is bonded to 2 other carbon atoms and an oxygen, while the aldehyde is bonded to the carbon, the oxygen, and then a hydrogen. So aldehydes, so the functional group of aldehydes only happen at the end of a hydrocarbon chain. Okay, functional groups are aldehyde and carbonyl. Suffix is anal and anone. Okay, the key difference is the ketone is bonded to 2 other carbon atoms, while the aldehyde is bonded to a carbon atom and a hydrogen. Okay, moving on, even more. These get a bit more trickier. So carboxylic acid is when it has that carbonyl group we were talking about and an OH. That makes it an acid. So that functional group together is called a carboxyl acid, and the name is enoic acid. Then there are esters. Those are we'll actually look into how those are made, but it's basically when you react an alcohol and an acid together. Ether is when 2 carbons, then oxygen in the middle of them. Nitrile is triple bond of a carbon to a nitrogen. Amine is carbon, nitrogen, and then whatever the nitrogen is attached to. And amide is carbon, then a carbon bonded to an oxygen, and then the nitrogen. The difference between an amine and amide is the carbon double bonded to the oxygen. It's present in an amide, it's not present in the amide. Again, if you want to ask me again at the end, I don't mind going back to it. Okay. Okay, so those are all the ones you need to know, all the classes you need to know. It's a long list, but key thing is just to keep looking at it before your exam, and hopefully they'll sink in. The one last functional group you need to know, this isn't a class, it's a functional group, and this one's called phenol. So phenol is essentially a benzene ring, like what we saw before, but instead one of the hydrogens on the carbon is replaced with an OH group, so it becomes an alcohol. Okay. So now we'll have a look at substituent groups, and this is all leading to how we name compounds. So substituent groups are when you have a carbon chain and then you add something on the end. So you replace one of the hydrogens with a substituent group. If it's like CH3, it's called methyl. If it's CH2CH3, it calls ethyl, propyl, butyl, and that just the name depends on the number of carbons there are. Amino is when you add an NH2, and then when you add halogens, it becomes chloro, fluoro, bromo, or iodo. Iodo for iodine. Yeah. Okay, so how to name. So we need to, the first step is to find the longest carbon chain. So you have to count the number of carbon atoms. One carbon atom, it's called meth. So we have methane, methanol, so on and so forth. Then 2 carbon atoms is eth, like ethene. Then we have prop for 3 carbon atoms, but, like butanol, butane, butene, butanitrile, so on and so forth, pentane for 5, and hexane for 6. This is super important that you guys memorize these because they will crop up all of the time. Okay, now this is how we name them. So I'm just going to turn the light on. So this is how we name them. We first find the longest straight chain hydrocarbon. Then we name it based on the functional group and the number of carbon atoms it contains. Then we number the carbon atoms. One should be the end closest to the functional group. And then we identify the side chains or substituent groups, and we name them by number dash name. I don't know how well you guys know how to do this, so I'm going to give you guys a question first, and then we're going to go step by step as to how to solve it. This is the question. It's HCC, and then it's CH3 on the top of the second carbon atom, and then CN. I'm going to give you guys like a minute or two to like try and solve this question on your own. If you guys need me to pop back to this slide, let me know. And it gives you 4 different, it's multiple choice, 4 different answers. Try and guess which one, and we'll work through it step by step together in a couple of minutes. So find the longest hydrocarbon chain, then name it depending on the number of carbon atoms it contains and its functional group, then find its substituents, if there are any other added groups. Okay, 10 more seconds, and then we'll go through it together. Okay, I hope you guys got C as your answer. So I hope you got your answer C. This is basically what the molecule is meant to look like. So we have, it was 3, oh, okay, yeah. So I hope you guys, I'll just zoom in a bit further. No, that's as big as it's gonna get, I'm afraid. Just try one more thing. Okay, I hope that helps a little bit. So this is, okay, essentially your molecule. As we can see, there were 3 carbon atoms, right? I'm sorry, I can't I actually see like what I'm doing without it. So this is just what you were given. So there were 3 carbon atoms, and either way, so now the first step is to find the longest carbon chain. This is 3, this is 3, and this is 3. So it doesn't actually really matter which route we take. We just know that the longest carbon chain has 3 carbon atoms in it. Okay, so we know that the prefix has to be prop. because 3 carbon atoms gives us the prefix prop. The functional group is a nitrile group. So the ending has to be propanitrile. So this is the first step. Okay? The second step is to number it with the first carbon atom being closest to the functional group. So we label 1 here, 1, 2, 3. It wouldn't really matter in either way because since there are 3 and it falls right in the middle, it would be number 2. But just for longer molecules, that's important. Okay, then we have to identify the substituent groups. These are methyl groups. We looked at them beforehand on the presentation, and there are 2 of them. If there are 2 of them, instead of repeating it endlessly, we can just say dimethyl. Okay, so we have 2 methyl, then 2 methyl, so we can write 2,2-dimethyl propanitrile, which is answer C. Okay? The reason it's not pentanitrile is because we have to, the CH3 and the CH3 are like branched, so we have to acknowledge that. The reason why it's not 2-methyl-2-propanitrile is because they forget to write 2-methyl, so like after the second 2 they forget to write methyl. If they had written that, that's another respect, like it's a proper way of writing it. And the reason why it's not 1,1-dimethyl ethanitrile is because you have to number it with the carbon atom closest to the functional group, which is CN, and the methyl groups are not attached to that first carbon atom over here.